Scientists have created the first map of a colossal supercluster of galaxies known as Laniakea, the home of Earth's Milky Way galaxy and many other. This computer simulation, a still from a Nature journal video, depicts the giant supercluster, with the Milky Way's location shown as a red dot. Credit Nature video in space, we're used to dealing with large distances and objects. In the cosmic scheme of things, Earth is rather small. Even in our solar system, we are easily dwarfed by the planet Jupiter. More than 1,000 Earths would fit in the planet, according to NASA, and our Sun more than 1,000,000 Earths would fit in there, according to Cornell University. Even our Sun looks puny when it is compared to the biggest stars we know of. The Sun is a G-type star, a yellow dwarf, pretty average size on the cosmic scale. But some hypergiant stars are much, much larger. Perhaps the biggest star known is Scuti, which could fit more than 1,700 of our suns. It is only about 30 times more massive, however, so that shows that mass and size don't necessarily correlate in space. Progressing up the list of big cosmic objects, other things to consider are black holes, and in particular, supermassive black holes that typically reside in the center of a galaxy. Our Milky Way hosts one that is about 4 million times the mass of the Sun. The biggest supermassive black hole is roughly 21 billion times the Sun's mass, and lives in the Coma cluster, which includes more than 1,000 galaxies. As the last paragraph hints, there are things out there bigger than even supermassive black holes. Galaxies are collections of star systems and all that is inside those systems, such as planets, stars, asteroids, comets, dwarf planets, gas, dust, and more. Our own Milky Way is about 100,000 light-years across. NASA says a light-year is the distance light travels in a year. It's difficult to characterize what the largest galaxies are, because they don't really have precise boundaries, but the largest galaxies we know of are millions of light-years across. Now at last we are starting to approach the biggest structures in the universe. Galaxies are often bound to each other gravitationally in groups that are called galaxy clusters. The Milky Way, for example, is part of the small local group that comprises about 24 galaxies, including the Andromeda Galaxy. At first glance, astronomers thought that these structures were the biggest thing out there. In the 1980s, however, astronomers realized that groups of galaxy clusters are also connected by gravity and connected in a supercluster. The biggest supercluster known in the universe is the Hercules Corona Borealis Great Wall. It was first reported in 2013 and has been studied several times by teams led by the same person. It's so big that light takes about 10 billion years to move across the structure. For perspective, the universe is only 13.7 billion years old. The structure first came to light as the research team led by István Horváth with the National University of Public Service in Hungary was looking at brief cosmic phenomena known as gamma-ray bursts. It is thought that they come from supernovas, or massive stars that explode at the end of their lifetimes. Gamma-ray bursts are thought to be a good indication of where huge masses of stuff lie in the universe, because big stars tend to congregate in dense areas. The first survey showed gamma rays particularly concentrated about 10 billion light-years away in the direction of the Hercules and Corona Borealis constellations. But it's a puzzle as to just how that big structure actually came to be. A 2013 article from Discovery News, a partner site to Space.com, pointed out that this structure appeared to go against a principle of cosmology, or how the universe formed and evolved. Specifically, this principle says that matter should be uniform when seen at a large enough scale. The cluster, however, is not uniform. I would have thought this structure was too big to exist. Even as a co-author, I still have my doubts, John Hakila, an astronomy researcher at the College of Charleston in South Carolina, said in a 2014 press release. He said there is a very small chance the researchers saw a random number of gamma rays in that location, but it is far less than 1 in 100. Thus, we believe that the structure exists, he added. There are other structures that appear to violate universal homogeneity, this lone Great Wall and the huge large quasar group, or two. Thus, there may very well be others, and some could indeed be bigger. Only time will tell.